Nice to see so many handsome people. Welcome to middle of Norway. Trondheim is not middle of Norway, but it's the middle of Norway. That's a very different. And it's an extremely nice place to be situated when you're doing development of Bluetooth radios. Because here you have the brain power of Bluetooth smart radios. And my team is going to be with you guys for 2 days to show you the next generation that we are launching today. I think you're going to be dead excited. I am. And you know, all of you have been working with our 51 chip. In 2012, when this chip came on board, we changed the game. Bluetooth low energy became Bluetooth low energy with the 5100. So we used the Cortex-M, flash. And I see some of our competitors coming out with parts just a couple of months ago that still use Cortex-M0. I think that through this presentation you will see that we don't release a new chip today with Cortex-M0. We had a multi-protocol radio. Some of you guys are using ANT, proprietary, using Bluetooth Smart. Nordic offers this due to the smart, good architecture. And we spend a lot of time on our architecture. We believe it's the best software architecture out there when it comes to software. But that doesn't count so much. It's what you believe that really counts. So do you agree with me? Thanks. Is it easy to use? I love it. What about performance? Remember back in 2012. What do you think? Is it good? Better? Best? Exactly. And it's extremely popular with developers. If you look now, we shipped a huge amount of developers kit. I mean, as you see here, we've been having visitors of 25,000 people visiting our development zone each month. Tremendous growth. And I remember some 6 months ago, a guy, actually the CEO of Cypress, he released some Bluetooth Smart products. And he said, we know we're 2 years behind Nordic, but it doesn't matter because the market is not yet there. In a non-existing market last year, we did $63 million sale of Bluetooth Smart. It's pretty good in a non-existing market. Agree? Yep. Cool. And Nordic has traditionally been a proprietary product manufacturer. But last year, Bluetooth Smart creeped up to 38% of our revenue. And I think we have around 60% market share in Bluetooth Smart. And we are going to extend that with you, making it easy for you to make your next generation of end products. And I think the 52 will do so. So we have a slide here talking about numbers of active customers. And if you see back here, end of 2013, on our way into 2014, I know it's not so interesting for you guys because you're developers, but you know, for us to bring the next generation on the market, we need some income. So this is interesting for you too. These were our customers at that time that drove 63 million. This is the customer base when we exit 2014. So I'm pretty sure it's going to be a good year for Nordic with such extended customer base. And talking about customer base, here is some of our existing customers. It's all kind of applications. You have such beacons, activity monitors, smart rings. Where do you find smart rings? Who could think of making a smart ring? Is it Japan? Yeah! Of course, smart ring from Japan. Door locks. Who want to protect the houses? It's Danish. Of course, the Danish want to protect whatever they have. Toys everywhere. And have you seen this nice keyboard? It's an ultra-slim keyboard from one of our main companies, customers, Logitech. So you see, different segments are putting Bluetooth inside. What else do we want? We believe in electronics. We believe electronics is going to change the world. So Nordic has joined up with BBC, and it's a program called Make It Digital, where they use Nordic radio to teach young kids electronics. So when this generation grows up, they all know the 55 or 56 series of products, which they're going to put into the products they're developing. And remember one thing, if you should remember one thing from this session we are going to have the next 2 days, we are very bold and we are extremely ambitious. We want to be the leader. But what do we need to achieve to be the leader? We need to communicate with you guys so we can get input from you to put the right functions into the parts. That's the most important thing that our engineers can do, is to understand your needs. So don't be shy. You should be bold and ambitious too. Just ask and ask. More you ask, better products we deliver next time. Because we want to excite you guys. We want to give you what you want. And I think what Thomas is going to present later on today, if that doesn't excite you, I don't even want to think that thought, because it will. We want to enable innovation. I want each of you guys to go back to your desk, to your boss, come up with a great idea, and become the star in your company. We are giving you the chance to be innovative. And if you want some help from us through these days, we are going to back you. I think we have a team of around 15 to 20 people going to be around here. Be sure you can do and implement your application. I mean, innovation is what brings the world going forward. And I'm pretty sure that you are the right guys to achieve this. And your management like to accelerate your market. And your market growth is important for your management, same as it's important for me. I want to be sure that we are understanding the opportunity we have now to really make Bluetooth Smart the leading technology in low-cost, high-volume, low-power applications. And we're all responsible for that to happen. And my aim is that my guys can basically assist you to make your market grow. I don't think I should take much more time. I just want you to be happy. And I would like to give you a toast and thanks for coming all the way up to mid of Norway. Cheers. Then I hand over to Thomas.
All right. I think we should get started. Quite a few things to cover. 52 series is bold and ambitious. It is about taking nRF51 to the next level. It inherits all the great things that we packed into 51 3 years ago, including the multi-protocol radio supporting Bluetooth, ANT, and proprietary. It inherits the software architecture of nRF51, and it inherits the ease of use and the flexibility of the SoC architecture. But it provides a massive leap forward in terms of performance for the radio itself, but also for the processor. It provides barrier-breaking power efficiency. So again, active current on the radio, active current on the CPU, and the overall and improved power management scheme that allows you to squeeze out the last microamps on your power budget. It is about pushing the envelope on single-chip implementations, meaning that applications you today have to use external microcontrollers in combination with the Bluetooth smart chip, you can do single chip with nRF51. If you have designs today that's already using single chip, 52 enables you to take those designs to the next level, packing in more features, delivering more performance with no compromise on battery lifetime. 52 series is architected for speed. We built a brand new multi-protocol high-performance radio for this chip series. It features, of course, support for all the latest and greatest Bluetooth Smart technologies. It provides support for ANT, and it provides support for proprietary 2.4 gigahertz. The ARM Cortex-M4 is clocked at 64 megahertz and provides a unique combination of generic compute power and hardware-accelerated DSP and floating point instructions. Embedded flash, true embedded flash on chip, delivers lower power and higher performance compared to alternative solutions that is using stacked die sort of flash. We have multi-segment RAM where the different segments have their own bus slave, so they can communicate directly with the peripherals. That combined with a multi-level AHB bus and ECDMA means that this fast processor is not slowed down by bottlenecks in the overall system. We built this chip in a cutting-edge process. We have collaborated with our long-term partner, TSMC, and we built it in a 55-nanometer ultra-low power embedded flash process. So compared to 180 nanometer that we built the 51 series in, this is a completely different league. It enables us to take the performance truly to the next level, but at the same time, slash current consumption. It enables us to pack in much more features, much more RAM, but at the same time, get a smaller chip. The chip delivers record-breaking performance. The radio has a sensitivity of minus 96 dB, and it's capable of an output power up to true 4 dBm. That's a 100 dB link budget on a Bluetooth smart radio. That's 5 dB more than nRF51, and that's close to the double in terms of radio performance compared to nRF51. The processor delivered 215 CoreMarks. CoreMarks is an industry benchmark for generic compute power. So 215, just to put it in perspective, that's about 6 times the performance of nRF51. Thanks to the floating point and DSP acceleration in the Cortex-M4, this processor will deliver up to 2 times the performance when it comes to DSP code compared to an M0 or an M3 clocked at the same speed. For floating point, it's close to 10 times the performance of an M0 or an M3 clocked at the same rate. That means that in terms of DSP, it's close to 12 times as powerful as nRF51, and in terms of floating points, it's close to 20 times as powerful as nRF51. So again, totally different league, massive leap forward in terms of performance. So why do we pack this sort of compute power into a chip? Is it really needed? We think yes. We see there's a rapid growth in the need for compute power in the industry. If people doesn't already have a requirement, they will figure out something cool to do with this processing power. But it's very real today, and it's probably fair to say it's been spearheaded by wearables, packing more and more different sensors, doing more and more advanced sensor computations to deliver, an improved user experience. The same wearables have displays. You want to generate graphic and run them on the displays. They have advanced user interface. We see advanced security sort of coming along across a whole range of applications, ranging from application-level link security all the way to internet-class end-to-end security solutions like DTLS and TLS being used on Bluetooth Smart SoCs. So all in all, we need more compute power. Not just generic compute power in terms of CoreMarks. The market needs DSP, and the market needs floating point to continue innovation in these sort of applications. If we have a look at how this chip stack up against competition when it comes to processing performance, it's simply the world's most powerful Bluetooth Smart SoC. So the first line on this bar here is CoreMarks. The next one is DSP and floating point. And if we compare it with competitor A, and competitor A is a Cortex-M0 based system on chip, clocked at 96 megahertz. I don't think this chip is generally available yet. They don't really provide hard specs on any of these figures, but we've estimated approximately, based on the other numbers they have, what sort of CoreMarks they have. We like and respect these guys, so we have been nice. We've said, okay, executing code from the flash you have is going to give you a 10% penalty on the ideal M0 CoreMark per megahertz. So that's putting them at around 200 CoreMark, which is a little bit less than 52 series. But then, as soon as there is an element of DSP, we're 2 times better. As soon as there is an element of floating point on floating point, we're 10 times better than this chip. Next one is a 48 megahertz Cortex-M3. And you can see that in terms of generic compute power, we deliver close to 50% more compute power than this chip. In terms of DSP, 3 times the DSP performance, and in terms of floating point, close to 14 times the performance. The last one is also a Cortex-M4F. This one I don't believe is sampling yet either. They have a great marketing campaign going on. They're very fussy on the specs, but we simply assume that, let's say their implementation is as good as ours, but we use their clock speed, which is 40 megahertz. This means that we're across the board DSP generic computing 60% better than this solution. So 52 series is the world's most powerful Bluetooth Smart SoC, period. This level of performance is not unheard of. I mean, you can get external microcontrollers and so on that delivers this, and they deliver more. But the point is, that's fair if you don't have power constraints. We have power constraints on our SoCs because we need to deliver very low power solutions. So the unique thing about this system on chip is that we combine this record-breaking performance with extremely low power. And there are 4 elements to doing that. One is to make sure we have very low active currents, specifically on the CPU and on the radio. We combine that with very low power, with very low sleep currents, and then we put in several mechanisms into the SoC architecture, enabling us to offload the CPU so we can do a lot of tasks without involving the CPU. And finally, to squeeze the last microamps out of the system, we have an improved automatic power management scheme. So let's look at the fundamental parameters first. This is a 5.5 milliamp radio, so sub 5.5 milliamp in RX and TX. The processor runs at 38 microamp per megahertz. That number is close to that number is close to 1/5 of nRF51. But microamp per megahertz is not the best benchmark for power efficiency on a CPU, because it doesn't take into the account that an M4 does more per megahertz than an M0 or an 8-bit microcontroller. A better benchmark is CoreMark per milliamps. It's a measure of how much computation you can do per milliamp you supply the processor. And the nRF52 delivers 90 CoreMarks per milliamp. That, again, thanks to the DSP and floating point hardware in 52, we can use that extra performance to squeeze power consumption, because hardware-accelerated DSP means that the processor will spend less time on DSP instructions. So it's like trading performance for power. So compared to an equivalent M0 or M3, it's half the current for the equivalent DSP instructions and 1/10 of the current for the equivalent floating point instructions. Again, looking at the processor here, 52 series is really record-breaking. It's the world's most power-efficient Bluetooth Smart SoC, period, by a good margin. If you compare it to competitor A there again, we're about 40% more power efficient than them. We're at 90 CoreMark per milliamp, they're at 64. Close to 3 times as efficient for DSP and close to 14 times on floating point. Comparing with chip B, which is a Cortex-M4 implementation, we're about 60% more powerful across the board. And then the last one, the M3 at 48 megahertz, we have 2 times the generic compute power. 2 times as power efficient, but with 3 times more power efficient on DSP and 20 times as power efficient on floating point. So in terms of power efficiency on the processor, nothing is even close to this new chip. The radio provides a unique combination of low power and performance. So if you compare this radio to other radios with sort of similar performance, you'll see that this one consumes up to 30% less current than those radios. If you compare it to radios with similar current consumption, you'll quickly see that we provide up to 8 dB higher link budget. And performance matters. So, for example, range, and I'm not necessarily talking about the range as in we can do 200 meters outside, that's maybe not that interesting, but being able to maintain the link in difficult RF conditions, that's what's performance about, and that is about end-user experience. So is link reliability and link robustness. Keep on losing the link and you're going to have unhappy end users. So performance matters. We didn't want to sacrifice any performance for power in this chip. We wanted power to go down and performance to go up. That's where it needs to be. One thing which may not be that obvious for everyone is that radio performance saves power. 100 dB of link budget combined with best-in-class coexistence performance means that this radio on average loses less packets than other radios. So let's say you have a system where you lose 20% of the packages. In Bluetooth Smart, it means you have to retransmit 20% of those packages, which means you're going to spend 25% more time on air consuming current to retransmit packages. So again, performance saves current. It is not obvious on the peak current of the radio, but it is the fundamental mechanism of it. Disconnects in Bluetooth Smart can be very expensive from a power perspective. When you lose enough packages so that the link disconnects, there's a number of transactions back and forth that has to happen before the system starts working again. So just ignoring the usability aspects of it, it saves current to have a high-performance radio. So again, it's high performance, and at the same time, that performance saves power. Typically, when you see the sort of performance that we deliver here, the sort of active currents we deliver here, you'll expect to see a compromise on sleep currents because it's in the nature of the process and the architecture of such feature. 52 is not a compromise on sleep currents, quite the opposite. It's one step better on sleep currents too. Our engineers have just done a fantastic job here. So off mode is 400 nanoamps. On idle is 1.2 microamps. On idle with RTC is 1.6 microamp. And then there's configurable RAM retention, 4K blocks, each consuming 49 nanoamp. Comparing it with 51, it's about 50% better on the sleep currents. And keep in mind, this is a significantly bigger chip in terms of digital and functionality and the ambit of RAM and flash. So, we have very low sleep currents, and we have a very low power processor. But still, if you look at the ratio between active current on the CPU and the sleep current, it's about 2,000 times. So if you're able to minimize the activity on the CPU, there are massive power savings to be gained. In nRF52, we have two technologies that helps you to do that. The first one is ECDMA. ECDMA is DMA built into the peripherals that allows the peripherals to transfer data back and forth to the RAM independently of the CPU. The CPU can sleep while that's going on. In any system where there is a significant amount of data being moved around on the chip, this is a massive power saving. Second is PPI. PPI is Programmable Peripheral Interconnect. It allows peripherals on the chip to interact with each other independent of the CPU using a task and event system. So very simple example, let's say you have an application where you have an ADC that needs to sample a sensor at the periodic time. You can, with this system, set up a timer to generate an event on a periodic basis, hook that event from the timer into the start ADC task of the ADC, and it will just automatically happen periodically without the CPU involved, and then again, saving current consumption. We have an improved automatic power management scheme for squeezing out those last microamps in your system. There are two key elements to this system. One is pretty known from nRF51. It's called the automatic block start-stop. So in contrast to other solutions where you have to carefully manage the power of the different blocks in your firmware, nRF52 takes care of this for you. So essentially, when you need a block to do something, for example, the ADC or the SPI or the crypto block, it's being triggered by your software or your PPI, it does the job and it stops automatically. It means that less complexity on the power management in the software. The last one is new. In 52 series, we have something we call adaptive regulator control. In this chip, there are multiple regulators. There are multiple LDOs, there are multiple DC-DC regulators, and all of these regulators have different modes. And those modes are optimized for different current draws. Then, with the adaptive regulator control, it's continuously sensing the supply voltage, and it's sensing the amount of current that is being drawn on the chip. And based on these two things, it picks the optimum regulator, and it picks the optimum regulator mode to supply the chip at that point in time. We call this lowest power made easy. And I think the easiest way to understand, or the equivalent of this, is a top modern automatic gear shift. I mean, if you're really good, you can get pretty good mileage and performance out of a manual gear shift, right? But you've got to be good, and you have to work on it, you have to invest in it. But there is no way you can beat the mileage and the performance you will get with the top modern automatic gear shift box. This new power management scheme we have in 52, that's the equivalent of that automatic gear shift box. So we have lower power across the board, active currents, sleep currents, overall system efficiency. It means that we can take applications, do the same thing, and deliver incredibly longer battery lifetime. You can, instead of getting more battery lifetime, use a smaller battery, reducing the size of your end application. It's at the power level where we can actually support energy harvesting, so you can power beacons or even light switches from solar panels or from piezoelectric elements. But of course, you can take all of this performance and power efficiency, keep the same battery lifetime, but pack in more features and more performance into your products. So just use it to deliver something that's more fun. You don't have to use it just for battery life. All right? Switching gears a little to talk about single chip implementation. So when I talk about single chip, I talk about a chip's ability to implement a complete application without requiring an external microcontroller. And there's typically a few criteria you would hear. First of all, do you have compute power enough? And I think on 52, yes, we do have more than enough compute power. Do you have power efficiency? Is your compute power being delivered at a compromise in terms of power? 52, no. It's in line, and if not better than some of the standalone microcontrollers out there on power efficiency. Do we have memory enough? On this chip, first 52 series chip, we have 512 kilobytes of one-chip flash, and we have 64 kilobytes of RAM. That's ample room for even advanced applications. Do you have the interfaces to interface with external system? And I think we do. We have multiple higher speed SPIs. We have UART, multiple I2Cs. We have I2S and PWM interface and QDEC interface. We have a brand new 12-bit ADC, 2 different comparators, 1 low-power comparator and 1 general-purpose comparator. And we have 3 4-channel glitch-free hardware PWMs on this chip. That's a pretty comprehensive range of peripherals, but it is what it takes if you want to span multiple applications. SPI, I2C serial interfaces are perfect if you want to interface with sensors. The higher speed SPI is good when you're going to talk to displays. Hardware PWM, perfect for motors and LEDs. The PDM interface allows you to interface directly with MEMS microphones. And the I2S, you can interface with audio codecs. Even with this level of features, 52 series is the world's smallest Bluetooth smart SoC. So this feature chip we are delivering in a 3 by 3.2 millimeter CSP package. Thanks to an on-chip RF balun, the external bill of material is only 11 passives, and only 132 megahertz crystal is required for operation. So if you compare that to the closest competitor, they are at 3.2 by 3.3 millimeter, but it's half the flash and half the RAM. The next one is 4 times 4 millimeter QFN, and it's even less flash, so the more likely you got to have another microcontroller. And the last one, that's a huge one. I got to give them, they have some more flash on that chip, but hey, 6 times 6 millimeter, that's a giant compared to the small nRF52. 52 series is the world's smallest Bluetooth smart SoC. So with all of the things we've talked about today, it means that 52 delivers a single chip solution saving size, power, and cost for a range of different applications. So wearables like heart rate monitors, watches, and activity trackers, human interface devices, mouse, keyboards, voice recognition remote controls, single chip solution, smart home applications like door locks, thermostats, and smart lighting, single chip, toys, helicopters, cars, intelligent dolls. We pack enough peripherals and compute power to be the brain in those sort of applications. Finally, wireless charging. It's enough things on this chip to be able to run multi-standard wireless charging pads, and we can, of course, be in the rechargeable devices. One of the key things with nRF52, I think both for us at Nordic and I think also for developers, is that we provide a smooth software migration path from nRF51. The architecture of 52 is a superset of the 51 series architecture. It has the same software architecture, and it means that we are providing a rock-solid foundation for software development, not only for you, but also for us. It means that we are able to leverage the proven and feature-rich software we have for nRF51 and deliver that on nRF52 very, very early, today actually. So you start with something that's tested, done, run in the field. For developers, it means that you're building code on proven software. You can take all the investments you've done in 51, easily port it over to 52, and instead of spending time porting code to a new platform, you can spend your time innovating and doing new stuff instead. So, we are changing the game again with nRF52. It's built on the rock-solid foundation from nRF51. It's a massive leap forward in terms of performance. It's the world's most powerful Bluetooth smart SoC. It's barrier-breaking power efficiency, It's lowest power made easy. And with 52 series, we are pushing the envelope on single chip. We are sampling today. We have thousands of kits and samples in our distributor channel. So if you use your favorite catalog distributors and you place the order later today, you'll probably have the kits and samples on your desk before it's weekend. Later this evening, we roll out documentation, software, and tools on the web. So by Friday, you should probably compile your first application on this chip. I'm not done yet. Sorry. We're going to talk a little bit about pairing. Have you guys ever seen this message? It says, Bluetooth pairing request, GB54321 would like to pair with your phone, blah, 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 blah. It actually makes a lot of sense to me, this message. I see it all the time, and I type in the password, and everything is good. It doesn't make that much sense for my mother. Sorry, Mom. So she's struggling with these things. And I think a lot of people are struggling with this. And ultimately, this is limiting the potential of Bluetooth Smart. There's got to be a better way of pairing than this thing. That's one of the things that we decided to tackle with nRF52. So in nRF52, we have the world's first on-chip NFC tag for touch-to-pair. We are seeing accelerated adoption of NFC in phones. We're seeing the operating system lining up and coming along with support for touch-to-pair using NFC. We believe that NFC provides a superior experience. It's fast, it's easy, and it's secure. And it's a much, much better out-of-the-box experience than any other thing that I have seen. So we'll take a risk to see if I can show you a demo of how this works, okay? Gotta have some water. All right, so what we have here is a brand new nRF52 series development kit. The antenna is, of course, not inside the chip, but the rest of the NFC circuitry is. I have here a new Nokia Lumia phone, which has built-in support for touch-to-pair using NFC. So I'm turning on the kit like this. And this is now rigged only to be able to pair via NFC. So it's not advertising or anything at this moment in time. And we can go in here to the Bluetooth menu. And we can see that it's not here. This one is Nordic HRM. And we go back. And with my new peripheral, I touch the system. And I get this message, would you like to pair with Nordic HRM? This will turn on Bluetooth. I say pair, and we're done. That's how we think pairing should be done. So touch to pair, easy, fast, and secure, on-chip NFC tag on nRF52, NFC stack, example software for touch-to-pair. We kick it all off tomorrow. We have more than 60 developers in this room that has been invited for a 2-day developer conference here in Trondheim. There's going to be presentation, there's going to be hands-on with kits and with software, and everything by the team that actually developed nRF52. Not from anyone else, by those who actually built it. Then, I hope to see you all at the nRF52 Global Tech Tour. We are running that one from October to December 2015. This time, we have 10 weeks on the road, 26 locations, 13 countries, and we expect to have 5,000 developers attending these events. Again, we're putting on the road the key engineers behind nRF52 to give you sort of the face and direct interaction with the engineers at Nordic. And that's it. That's nRF52, and thank you very much for spending time with us this afternoon.